Hello kids. So today's topic is about expansion of solids. On heating. Okay. So we already know that if we heat a substance, it expands, right? Okay. So there can be three types of expansion, right? Okay, there can be three types of expansion. One is linear expansion. If there is a rod and if you heat it, it will expand, right? Linear expansion. Second is areal expansion. If there is a metal sheet of some length and breadth, it will expand from all the sides, right? Okay, that expansion is called as areal expansion. Third is volumetric expansion. Okay, if there is some solid substance having a particular volume, okay, then if we heat it, it will expand length, breadth and height all the ways. So that particular expansion is called as volumetric expansion. Okay, so let's dig this in. Let the length of a particular rod, initial length be L1, and after expansion let it be L2. Okay, so now what they say is the change in length, okay, the change in length, okay, that is L2 minus L1 will be directly proportional to its original length, that is L1, right, and the change in temperature. Let the earlier temperature be T1 and let the next be T2. So what will be the change in temperature? T2 minus T1, or we can say that delta T, right? Final temperature minus initial temperature. Change in temperature is delta T. We have talked about this in our earlier video. Okay, so L2 minus L1 is directly proportional to L1 into delta T. Okay, whenever we change the proportional sign with equal to sign, okay, so we put a constant, right? So let this be a constant. And what do we call this constant? Okay, constant means any number. Okay, जब भी proportionality के जगह पे equal to डालते हैं तो हम लोग वहाँ पे एक constant डालते हैं, like you do in your maths. X is directly proportional to y, so x equals to ky. K is constant of proportionality, right? ऐसा करते हो, right? Okay, so same way in science. ओके, प्रोपोर्शनलिटी के जगह पे इक्वल टू आया तो एक कांस्टेंट हम लोग वहाँ पे इंसर्ट करते हैं, राइट? दिस कांस्टेंट इज कॉल्ड एज लीनियर एक्सपांशन कोएफिशिएंट. लीनियर एक्सपांशन कोएफिशिएंट और कोएफिशिएंट ऑफ लीनियर एक्सपांशन. ओके, कोएफिशिएंट ऑफ लीनियर एक्सपांशन L2 minus L1 equals to lambda into L1 into delta T. Okay, we can derive something from this too. Okay, suppose तुमको कोई बोलेगा कि define linear expansion coefficient, so हम लोग ऐसा कर सकते हैं, इसको ऐसे रखो, बाकी ये दूसरे साइड L2 minus L1 into delta T. Now think that suppose वो rod जो है, right, उसका change in length is unit. Okay, only one. ठीक है, चेंज इन लेंथ जो हुआ वो सपोज, चलो इसको हम लोग लेते हैं 1. ओके, मीन्स वो रॉड जो था वो 1 मीटर का था, राइट? और सपोज टेम्परेचर भी इंक्रीज़ किया हमने बाय 1 डिग्री सेल्सियस, सो चेंज इन टेम्परेचर भी 1. ओके, अगर ये भी 1 ये भी 1 तो लैम्बडा इक्वल्स टू चेंज इन द लेंथ, राइट? ओके, सो साइंटिस्ट लोग ने कैसे डिफाइन किया लैम्बडा को, लीनियर एक्सपांशन कोएफिशिएंट को? तो साइंटिस्ट बोलता है दैट लैम्बडा इज नथिंग बट, लीनियर एक्सपांशन कोएफिशिएंट इज नथिंग बट चेंज इन द लेंथ of the rod, okay, when its earlier length was unit length, that is 1, and when the temperature is increased by 1 degree Celsius. 1 डिग्री सेल्सियस से राइट अगर टेम्परेचर बढ़ाया और वो रॉड का अर्लियर लेंथ वाज 1 मीटर, तो जो भी चेंज इन लेंथ उस रॉड में होगा दैट विल बी इक्वल टू लीनियर एक्सपांशन कोएफिशिएंट. ठीक है. देन अच्छा और एक चीज़, सपोज व्हाट वी डू इज, अगर L2 को यहाँ पे रखते हैं, ठीक है, दिस इज इंटरेस्टिंग. वी कैन गेट n नंबर ऑफ फार्मूला फ्रॉम ओनली वन फार्मूला. आई लव दिस फार्मूला, बट बाय द वे दिस इज द ईजीएस्ट वन टू रिमेंबर. ओके, बाकी टेक्स्ट बुक में सब टेक्निकल सब बहुत सारा कुछ दिया है, बट दिस इज द ईजीएस्ट वन. चेंज इन लेंथ इक्वल्स टू लैम्बडा इंटू ओरिजिनल लेंथ इंटू डेल्टा टी. सपोज वी पुट दिस L1 that side, so the new length will become, this L1 goes that side, so it will become positive, plus already it was L1, lambda and delta t, right? Okay, see these three and L1 common, 1 plus lambda delta t. So this is a new formula, that the new length is the original length into 1 plus the linear expansion coefficient into change in temperature. Think of this. ऐसे ही सेम करते करते हमको एरियल एक्सपांशन के लिए भी कुछ मिलेगा. यू नो व्हाट, लेट A2 बी द न्यू एरिया, A1 बी द ओल्डर. 1 plus lambda is linear expansion coefficient. For areal expansion coefficient we put sigma. Okay, and delta t. Wow, same. And for volume also same. Let V2 be the new volume, V1 was the old volume, 1 plus, and volumetric expansion coefficient is beta. Okay, this is lambda, this is sigma, and this is beta. Okay, right? Easy. So let's have one numerical for this. Okay, so the question is, what will be the increase in length of the steel rod? What will be the increase in length? Increase in length means it is asking delta L, means length 2 minus length 1. He is asking for this. Understand, whenever they say increase in length or difference in length, it means that L2 minus L1. Okay, now what they are saying is the temperature is increased by 60. Temperature is increased by 60 degrees Celsius. It means that what they are directly giving us is delta T, 60 degree. Okay, initial length of the rod was suppose 0.5 meter. Okay, so now use the formula L2 minus L1. L2 minus L1, we have seen this, right? L2 minus L1 equal to lambda into L1 into delta T. They have given the value of lambda for steel. Lambda for steel, we are using a steel rod here. Lambda for steel is 0.000013, or we can also write 1.3 into 10 raised to minus 4, right? Okay, 1 2 3 4 5, 10 raised to minus 5. Okay, so done. L2 minus L1 they are asking. Lambda is 0.000013. What is L1? Original length is 0.5. What is change in temperature? 60. Okay, you multiply all these things, you will get 0.00039 meter. Okay, if they ask you that what is the increase in centimeter, what we do is multiply by 100. So we'll get the answer in centimeter. 100, 2 decimal shift. Okay, so 0, 1 and 2, 0.039 centimeter. Okay, let's do one more. So the question is, this is an interesting one. Okay, if the length of Eiffel Tower, okay, suppose this is my Eiffel Tower. Okay, if the length, okay, height of Eiffel Tower, okay, is 324 meter, so it is actually L1, right? Okay, length of the Eiffel Tower is 324 meter. Okay, then this is that 15 degrees Celsius, so it is temperature 1, right? Initial temperature 15 degrees Celsius. Okay, if it is made up of iron, what will be the increase in length in centimeter at 30 degrees Celsius? So T final equals to 30 degree Celsius. If T initial is 15, T final is 30, what is the difference in temperature? T2 minus T1, T final minus T1, delta T equals to 30 minus 15, 15 degree Celsius. And length 1 is already given to you, right? Okay, so what is asked is, what will be the increase in length? So they are asking increase in length. It means they are asking delta L, means they are asking L2 minus L1, right? Okay, so let's put the formula. Okay, they have given the value of lambda for iron. Okay, and what is that value? That value is 11.5 into 10 raised to minus 6 meters. Okay, this is in meters, 4 meters. Okay, then we have the formula for lambda. We can derive the unit for lambda. See, this is in meters upon this is in meters, and this is in degree Celsius. So meter gone. What we get is per degree Celsius. It means that the unit of lambda is per degree Celsius, the unit of sigma is per degree Celsius, the unit of beta is per degree Celsius. Important question, right? So, but this value comes when we do the calculation in meters, so we have to remember it. So let's do it. So let's write the formula. We have already written L2 minus L1 equals to lambda into L1 into delta T. Okay, what is lambda? 11.5 into 10 raised to minus 6. What is length 1? Length 1 is 324 meters. Length 1 is 324 meters. To convert meter into centimeter, multiply by 100. Important. Into what is delta T? 15. So if you multiply this, you will get 55890. I have calculated it earlier, that's why. Okay, this is 10 raised to minus 6 and this is 10 raised to 2. Okay, 55890. You know the maths, right? A raised to m into a raised to n equals to a raised to m plus n, minus 6 plus 2 minus 4. 10 raised to minus 4 means 4 decimal back, 1, 2, 3 and 4. 5.5890 centimeters, approximately 5.6 centimeters. So change in length of the Eiffel Tower. Okay, if we change the temperature by 15 degree Celsius, अगर 15 डिग्री सेल्सियस बढ़ाया तो आईफल टावर का लेंथ 5.6 सेंटीमीटर से बढ़ जाएगा. Awesome, isn't it? Okay, let's do one more. Okay, this we have, I guess we have done it already. The concept is already done. Q equals to m into C into delta T. Yeah, I got that question. Interesting question. The concept we have already done. Okay, so watch the earlier video on introduction to heat, numericals on heat. Q equals to m into C into delta T, right? Okay, mass, specific heat capacity. For water it is 1, and delta T change in temperature. So what is the question? Okay, the question is that two substances A and B. There are two substances A and B. Okay, and the heat for A is Q and the heat given to B is 4Q. The specific heat capacity for A is C and specific heat capacity for B is 2C. To C great ho, right? Okay, sorry. The change in temperature delta T for both of them is same, delta T. Okay, if the mass of A is m, what is the mass of B? ओके, जब भी ऐसा क्वेश्चन आता है इट्स इंटरेस्टिंग. ओके, क्या करना होता है, 2 बार सेम फॉर्मूला लिखना होता है फॉर ए एंड फॉर बी. देखो मैजिक. फॉर ए क्यू फॉर ए मीन्स क्यू इक्वल्स टू मास ऑफ ए मीन्स एम, सी फॉर ए इज सी and delta T. For A this is 1. Okay, now interesting. For B, Q for B is 4Q, right? M for B we don't know, MB. What is specific capacity of B? Twice 2C and delta T. This is 2. Okay, divide this. Let us divide equation 2 by 1. What we get? We get is 4Q upon Q. This is MB 2C into delta T. This is MC into delta T. This is same. This is same. This is same. This 2 gets this side, so it becomes 4 upon 2. M goes this side, and you get the answer. MB equals to 2M, twice the mass. Okay, this I haven't included in my last video where we have discussed Q equals to M into C into delta T. That's why I have included here. Okay, so go through this video again. Okay, this is an important concept and a little tougher one. Okay, so do your best for your exams. Bye.